The distributive property is the reason that there are two different ways to calculate the area outlined in red on your screen. Remember that the area of a rectangle is its length multiplied by its width. One option that we have for finding the area outlined in red would be to find the area of the green box and the blue box and add them together. So the area of the green is 2 times 3, which is 6. And the area of the blue, if you think of this line as also being a 2, the area of the blue would be 2 times 4, which is 8. So one way to find the area would be 2 times 3, which is 6, plus 2 times 4, which is 8, for a total of 14. And whatever we're measuring in square units. Another way to find this area would be to realize that this whole side up here is 3 plus 4, which means that that's 7. So now we can multiply 2 times 7 to get the area, like this. So 2 times 7 is 14, also square units. So what we see here was that we could multiply the 2 by the 3 and the 2 by the 4 and add the answers together to get 14, or we could add the 3 and the 4 together first and then multiply 2, and we would still get 14. What's happening is that we're distributing the 2 to the 3 and the 2 to the 4 and then adding. It doesn't matter when it happens. This is the heart of the distributive property. So whenever I have a number multiplied by an expression in parentheses, like you see on your screen, the distributive property tells me what to do. I'm going to multiply the number on the outside by every term on the inside, and then add the answers together, like this. 5 times a, which I can write as just 5a, plus 5 times b, which I can write as just 5b, plus 5 times 7, which I'll write as 35. Now in number 2, it doesn't matter if the 7 is out in the front or at the end. This is exactly the same thing as saying 7 in the front times 5n plus 3. And you might always want to rewrite it that way because it's easier to think about. So in this one, I'm going to take 7 and multiply it by the 5n, and that gives me 35n. And then I'm going to take that 7 and add it to the 3 and add that on to the end. So 7 times 3 is 21, and I've added that to 35n. So how you use the distributive property is by multiplying the number on the outside by each part of the expression inside, and then you add the answers together, as I did above. And the reason you use this is to write an expression without parentheses. Later on in the course, you'll see why we want to do this. Now in this next example, we've got some subtraction going on inside the parentheses. We're still going to do everything the same. We're going to multiply the 2 times the 3x, using my little arrows to show you that. So 2 times 3x is going to give us 6x. Then we're going to add that, and we're going to multiply the 2 times the minus y. And just like before, you want to think of the negative sign as sticking to the y. So we're doing 2 times negative y, which is going to give us negative 2y. Then we're going to add that to our next thing, which is going to be 2 times negative 5, which is negative 10. Now, a good tip is that when you have a bunch of plus and negative numbers, it's easiest to just write that as simple subtraction. So 6x minus 2y minus 10, and that would be the best final answer. Finally, we're going to put distributing together with combining like terms, because frequently, once you're done distributing in a problem, there are like terms to combine in order to get the most simplified final answer. When we look at number 4, the first thing we notice is that we have 8 minus 3 out in front of this parentheses. And what we want to remember from order of operations is that you always multiply before you add or subtract. So what that means is that it's really only the negative 3, remember negative signs always stick on to the number after them, that is getting multiplied by the parentheses. So we're only going to distribute that negative 3. You can think of there being a little imaginary plus sign in there. This is 8 plus negative 3 parentheses 4 minus y. So I'm actually going to write just that. 8 plus, and then negative 3 times 4 gives me negative 12. And then negative 3 times negative y, remember the negative sign sticks onto the y, is going to give me plus 3y. The two negatives multiplied together give me a positive. Now in this answer, I see that I have two numbers, and you remember those are like terms. 8 plus negative 12 gives me negative 4. There are no like terms with the 3y, so I'll just leave that a 3y and call this my final answer. If we move on to number 5, there are two places we have to distribute. We have to distribute the 9, and we also have to distribute the 4. So in the first parentheses, I have 9a plus 9b, and then I'm going to add that to 4 times 3a gives me 12a, and then 4 times negative 2b gives me a minus 8b. I cannot leave this as my final answer because it contains like terms. The 9a and the 12a are like terms, and the 9b and the negative 8b, remember the negative sign stays with the number, are also like terms. So to complete my answer, I have to add 9a and 12a together to get 21a, and I have to add 9b and negative 8b to get just a single b. And this is my final answer. Your final answer cannot contain like terms. Always simplify.